I'm sharing my screen. You guys see my screen?
Yes.
Yeah.
Let me start. Yeah, this is a long paper, and I don't think I can finish them all. And I'm trying to deliver the key messages to you and get you familiar with what I'm doing in this paper. I'm going to see the importance of the information return, quality and returns at the same time. Yeah, I'll start with a very easy point, and the information would be a big deal if it is intrinsically informative, or the market is uninformative. So there are two interesting cases. Um, the poor information can be informative in an uninformative market, or the good information can be uninformative in an informative market. And I will spend some time to talk about the motivation of why I'm writing this paper. I think is more important compared to the tedious algebra. And the first question, the traders on the market should weigh the benefits and costs in information acquisition. And the benefits are the projected returns and we can get because of our more advanced trading strategies. And the costs are the information price, that is direct cost, and the efficiency losses. This is a micro principle thing. And if we have this is like a distortion, we should, if our demand is supply curve is not too extreme, and we will get a debt loss, and this is the efficiency losses. That's an indirect cost. And then I'm asking how this cost and benefits made. I think most of the literature they talk about they are only concerned about the information side reason. That is, the information quality can directly strengthen the information advantages, and but I also look at the market side reason at the same time, and I think it is a market randomness. But I have to clarify this is not the price informativeness because here I define the market randomness as the variance of noise trading. If it is more random and the information returns are higher. And so I have two ways to increasing the information advantages. If I can purchase the information of a better quality, or the information having higher returns, but the expenses are different. If I want a quality of better information of better quality, that means the cost at the same time higher. But if the information can give me high returns, but the costs are capped and not be affected so much, then there's a trade-off between these benefits and the costs. The model is in a dynamic setting, but actually I just roll the gross mistake model to the infinite period, and because the market states update over time. And actually, I'm concerned with welfare because the welfare is a indicator for pointing out why I'm thinking about these two margins of information. But I'm only concerned about the welfare change due to the information acquisition. There are two cases. The first case is a discrete case. It is a welfare difference between two states, the state of where no one purchases the information and the state where everyone purchases the information. In this case, there is no asymmetric information problem because the market is fully informed or uninformed. And another case, the continuous case, this turns on because some traders are informed, some other traders are uninformed. And the welfare function should be continuous in the information acquisition intensity that is defined as a proportion of informed traders. And the canonical experience says that the welfare cuts because of the information disclosures. But this paper finds there's some room for the net welfare gains. Then I'm asking, so what kind of traders' behaviors to explain the welfare change? The first behavior is about, I think, is information purchasing effect because the information is not free. And from a one-off per cost to, because I started with a per cost purchase for this information, but I look at the warfare in utils. So there's a mapping from them. So the mapping should be subjected to the risk assessments. They are varying with market states. And I'm not introducing market states, but I will talk this later. And the second effect is the information evaluation. I think it's a residual effect. It reflects the trader's evaluation about the information. It is a benefit cost analysis, but its cost only contains one margin because the other margin is a direct information price has been included in the IP effect. And the main hypothesis here is that IE faces a break-even state where information quality and returns work on at the same time. And the market states are actually the exposure to the risks. And it contains two parts. The first part is a set of parameters here, the row, the three rows, and the one row and the three taus. These four parameters are very, very standard in the literature. And so they are the risk fundamentals, but the other part of the market states are the information states from the Bayesian learning. And so the timing here is important because of the Bayesian learning, and I need the information rigidities, and my time is continuous. I add information rigidities because I'm trying to avoid the instant information spreading, because if I have the information spreading, on one hand, the information should be sold very, very expensively. On the other hand, if I use this information, my profits should be unbounded. So I have a graph I will show you shortly about the information rigidities. Then the last part, if I'm looking at the continuous case and the row of asymmetric information turns on, and the intuition is it's still about the IE and IP, but it's a kind of a different. So as the information acquisition intensity strengthens, the asymmetric information problem wins. But this is based on the assumption of strategic substitution. And I think I conjecture the marginal benefit from not utilizing the information increases, but at the same time, marginal benefits from utilizing the information minus the marginal cost of the information disclosure should decrease. And then the warfare from this IE effect should be convex. For the IP, in the same process, and the information price drops, and it changes the marginal cost. So the IP should be convex. These are my conjectures, and I will do some simulations to verify these conjectures. I follow the Grossman-Stiglitz 1980 very much. It leaves some room for me for this research. And I must skip this literature review part because time is limited. So I'll go over the model very fast because so before that, I was emphasizing the contributions of this paper. The model minimally deviates from the classic models, but have some meaningful implications, I think. And the importance of information quality and returns is important on resolving the Grossman-Stiglitz conflict. The conflict is between the information acquisition and the information spreading. And they altogether affect the welfare patterns because of the information acquisition. And thirdly, I have the chance for net welfare gains. This is really rare in the literature. And I have a full picture of the full picture about the welfare patterns. And I simulate the role of asymmetric information about the continuous case and see the convexity of my welfare patterns. Then the model is basically the Grossman-Stiglitz model and with some information rigidities. And I roll over to infinite time periods. And I have the information structure. The informational states are the Bayesian learning parameters, and the market risk fundamentals are the one rule and the three tails. And I have information shocks. The false shocks, they are mutually interdependent, so all the off-diagonal elements are zero. So the market states, I assume they evolve following a first-order Markov process. So we can write the phi m like this. It's just like ER1 process to the MA infinity process. And the information rigidities, I can show the graph. So the gamma t, the large period gamma is are the shocks. They only affect the market risk fundamentals. And then this risk fundamentals can only affect the Bayesian learning for the next period. So the rigidity means the shocks large period cannot directly affect the Bayesian learning next period, but the period after next period. This is information rigidities. The part B of the model is standard. It's just like Grossman-Stiglitz. This is an intra-period problem. We have the first order after the first order conditions. We have a demand schedules and the market clear conditions. They are very standard. I'm gonna go over very fast. And we have the conditional expected utility. You have questions? Oh, no. I have a conditional expected utilities for informed traders and uninformed traders. Then the market equilibrium is when the ratio of expected utility for informed traders over the expected utility of uninformed traders. If this is equal to 1, this is the REE. This is REE, rational expected equilibrium. Here's some kind of a different. I define two equilibrium. The borderline corner equilibrium. We have two, the lower one and the higher one. The lower one happens if the mu is 0, mu is a proportion of informed traders, and it is equal to 1. It's direct. It is actually satisfy the interior equilibrium condition and the corner equilibrium condition. These two conditions satisfied at the same time. And they are my two borderline corner equilibrium. Why I did this? Because I focused on the discrete case. Then I can back out the cost thresholds by using this equilibrium condition. Actually, this phi 0 equals 1 and phi 1 equals to 1. And I have two cost thresholds, and the KH and the K low. If the K it's higher than the KH, then no one purchases the information. If K is lower than the KL, everyone should go buy this information. And if K is intermediate, and then we have the continuous case. Then the Wurfer is defined as the expected utility for representative trader. But here the problem is I only look at the Wurfer for the informed traders and uninformed traders, but the Wurfer for noise traders, I think they are exogenous to the model, the problem, because of the three reasons. I write the expected utility for noise traders. So we can say that it is still related to the price, the market price. This is the same for the second order moment. So that means the distribution is not stable. Actually, the utility maximized behaviors are fuzzy. They can be the liquidity traders, or they're trading due to sentiments, or they are hedgers. Yeah, sure. And also, there are no Wurfer externalities between noise traders and non-noise traders. But so from the literature examples, if we are looking at the relative wealth effect, we cannot ignore noise trader, the welfare of noise traders, because we are concerned about the ranking of one agent in the whole population, the whole economy. But here, I don't think they matter. So I do not consider noise triggers the welfare change of noise triggers. There are two lemmas, and I write the welfare in each corner equilibrium, and then I define the numerator denominators and do some manipulations in algebra, and I can get the propagation one. This is the most important propagation for my paper, because I can directly express the information purchasing effect and the information evaluation effect. Let's see first. So I think it makes sense because the exponent 2 rho t KTL, this is a cost factor, but we can back out from the calculation. And then we have that one and that zero. That one is a slope, and that zero is intercept, all about the risks because they are in terms of the risk fundamentals. And we can say the delta D, the IP effect is always positive. Here from a higher corner equilibrium to lower equilibrium, if this welfare change is positive, it means that the welfare cost always. And in terms of the IE effect, it is now certain because for the second term, the tau ut over 1 minus big qt minus 1, because this can be positive or negative or exactly the zero. So the second IE effect, it can be welfare gains, welfare cuts, or break even, so no welfare change. So if they have the same sign and they strengthen with one another, if you have if the signs conflict, you have the overall welfare change depends on which one is stronger. This is the key intuition of this propagation. Then the IP effect, actually, the welfare costs are decreasing as KT decreases. That makes sense because this can lower the financial burden for the traders, and the welfare costs due to free information acquisition are non-negative because we have the efficient losses even if the information is free. And the IP effect is independent to KT if K is greater than K high, because the information is too expensive to buy. No one purchases this information. And the KT can be backed out, but in terms of the risk fundamentals, so the welfare can improve as the K changes. So the IP effect, I'm going to say that is 0 and Z1. And there is direct and indirect effect. And the direct effect is about the information side reason, the tau epsilon and the tau s. And if the first derivative is a semi-positive definite, or the second derivative is a semi-negative definite. So this is the direct effect, but we have an indirect effect. It's about the market set reason, and through the tau u and the rho, because you're not about the information per se. So it's just like an amplification compression of the direct effect, because it is working through the information specific parameters that we can see from the cross derivatives. And then this graph is very clear because we have two movements. If we change the that's 0, we have the shifts. If we change the Z1, we have a rotation. For the IE effect, I go back to Grossman-Stiglitz conflict. This conflict entails information quality is good enough, and at the same time, noise treating is not too strong. But this paper limits the information quality and disperses the noise treating. This gives a room for the 2 points. So the information spreading is capped, and then for information acquisition is motivated. If these two conditions satisfied, we will see the information, the welfare gains. And then I check the Hirschläfer effect, the 1981. So it says the welfare cost is due to the loss of opportunities for getting insurance. So if I let the tau s goes to infinity, and the fundamental theta, the average theta should be equal to the signal, and then we are fully insured. But in this case, the IP goes to 0, doesn't matter, but the IE matters. Here, the algebra tells me if the tau u is smaller than 1. So yeah, I think I missed one very important conclusion. So right here, so if the tau u plus qt is greater than 1 or smaller than 1, so this is the important condition to say the IE is a welfare cost or welfare gains. So the big QT is the relative information advantages. So if QT is always from 0 to 1, but the tau u measures the information returns. If information returns are very high, and tau u should be smaller. And if the tau u is very smaller, it is more likely for us to say the welfare gains. Then we're back here. If the tau u is smaller than 1, it causes no welfare cuts. These two statements, my statement, the Hirschläfer effect, are irrelevant. The Hirschläfer effect cannot tell anything happening here. But if the tau ut is greater than 1, then I still have welfare cuts. Actually, the Hirschläfer effect said the opposite thing about my statement. And the welfare patterns, I have the assumption I only change the one parameter, one risk fundamental each time, and keep all the 3 risk fundamentals, their effect mutual, the average effect mutual. Then I can back out the welfare patterns. The firstly, I look at if I give the impute shocks to tau u, and this is the welfare patterns. The red region is the net welfare gains, and the blue region, the light blue region is and the gray region of welfare cuts. But the dominance are different. Sometimes the dominance goes to the IP. Sometimes the dominance goes to IE. But I'm interested in the red regions because I want to see the welfare gains. The welfare gains only happen if the tau u is very small. If a tau u is, these welfare gains will disappear very easily if the tau u gets higher. And there are some details about the welfare patterns. When the tau u goes to 0, tau u goes to infinity, what happens? If the tau u goes to infinity, this information disclosure becomes useless, and we will see the welfare cut because of the waste of money. There's a recent paper published in JPE, and they use a Lucas-Allen model. They find the useless information disclosure can improve the welfare. That contrasts with my finding if I use Grossman-Stiglitz. Then the shocks to the tau epsilon, and the welfare will not be affected if tau epsilon goes to 0 because we have 0 information advantages. Also, if the information advantages goes to infinity, the welfare penalty should be going to the infinity as well. And then we have the welfare patterns, and we still say the red region for the welfare gains, but only for the panel A and only for panel A, because the tau u is smaller than 1, and the tau epsilon is still not high because it is absolute information advantages. If it is very high, so this will make the condition the tau u plus the big QT higher than 1, and then we will lose the welfare gains. actually the shocks to tau s is the other side of the changing the information quality, the relative information quality, because the relative information quality is about the ratio of tau epsilon to tau s. But the first conclusion here and the first conclusion with respect to tau epsilon responds to what I'm saying. The expenses are different if we increase the information quality and we increase information returns. Here, the red region only happen if the tau s is very high, because if the tau s is high, the information is poor. And this can be only thing if in panel A, where tau u is smaller than 1. And the last proposition is about the shocks to rho t. Yeah, following the same things, but the derivation might be more complicated. So we will still say the red region, the welfare cuts, welfare gains for the economy. So the last section is about the continuous case. The algebra is more tedious, and I have some. This is a welfare function, and the moments are here. I'm gonna skip them, and this is the gross domestic linear market price, and the welfare function can be written like this, and this proposition shows the welfare, the welfare function. It is a continuous in blah 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 something. So I have 4 conjectures. I will wrap up very soon. The first one is so as the pecuniary cost accumulated, the total welfare should drop. So the first order derivative should be negative with respect to IP. The second order derivative could be positive because as the information price drops, the welfare drops slowly as the information acquisition becomes more intensified, and the IP effect is convex. About IE, if mu is mu is a smaller between 0 to 1, and because this is a continuous case, and the first order derivative is positive as more informed traders and the marginal benefits from. I said this in the introduction, and not utilizing this information increases, but the marginal benefits from utilizing this information minus the fixed marginal cost of the information reading decreases, and the IE effect should be convex. And the second order derivative should be positive. The last conjecture is that IE produces welfare cuts. The IE, if I, sorry, that typo here. So the first order, the second, so it's really some typos right here. So the IE effect should be also convex. This is my last conjecture. So I'm doing some simulations to close this section, and I choose still for risk fundamentals, and I choose some intermediate values and low values and high values, and then I draw the pictures for each of them. I have 8 panels and each 2 for each risk fundamental. We can say here the convexity is very clear, and I'm going to verify the convexity for both IP and IE effect, and yeah, they are super consistent. That's it. I wrap up, and that's my introduction from this paper. Thank you.